All right, so welcome to the mastery review. So I'm going to share the mastery. Actually, okay. So what I'm going to do is I'm going to just go through each of the questions here. Here are the first three. If you have any questions on them, let me know. The first one, they may have differ from yours because you might have different numbers, but it's the same structural question. So for the first question, you have 7x squared minus 2x minus 20. Find the derivative. You just bring a 2 down, you get 14x to the first, take away 2. And then you just pop in the value a. And that's what you get. And stop me at any time if you have any questions, okay? For number 2, you have function 9 sine t, take away 2 pi cosine t, find its derivative. The 9 and the negative 2 pi are just coefficients, so they just go along. You need to know your sine and cosine derivatives. The sine derivative is cosine. The cosine derivative is negative sine. A lot of people forget that negative. All right, so the two negatives here make a plus sign here. And then again, the 9 and the 2 pi are just going along for the ride. For number 3, the function is 7 plus 2 over x plus 4 over x squared. I rewrote it so that the powers were, well, the x's were brought up, so they have negative powers. Then you take the derivative, the 7 just goes away. Bring down the negative 1, get negative 2 times x to the negative 2. Here you get negative 8 times x to the negative 3. And then all I did was just rewrite it so it looked prettier. Both answers should have been acceptable. Okay. The first case is just, it's correct. The second case is a little cleaner. Any questions on the first three? All right, let's move along. Let's look at 4, 5, and 6. 4, function f of t is 7t to the negative 5/7. Again, power rule, just bring down the negative 5/7. Just be careful with your arithmetic, and then subtract 1. You just got to be careful with that. Negative 5/7, take away 1 is the same as taking away negative 7/7. So you get negative 12/7. And then just wrote it like that. So I left it alone. Notice the 7s cancel, so that's nice. Alrighty. Number 5, I actually distributed the square root x, well, the 16 square root x through the parentheses. That way I didn't have to do the product rule. You could have done the product rule, but it's actually faster and cleaner if you just distribute. This is a case where the distribution is really quick. So it's probably better to not use the product rule here. Anyway, you get, this is x to the 1/2 power. This is x to the 1 power. So you get x to the 3/2 power. Then, of course, you just get x to the 1/2 after it distributes. Then you just take the derivative as normal. Bring the 3/2 down. 3/2 times 16 is 24. And then the power take away 1 is 1/2. 1/2 brings up in the front, negative 16 to the negative 1/2. And then I just kind of cleaned it up. So again, both of these forms here are equivalent and correct. I want you guys to get used to seeing them in their, I would say, more attractive form. Because I find a lot of students will get to this step here, but they don't know that they have radicals. They really don't know what they have. They just have this strange looking expression with 1/2 powers. In reality, here's what you have with the radicals. I think it looks a little cleaner when it's written this way. Number 6. Again, this one, you'd think you'd have to use the quotient rule. But boy, I wouldn't waste time with the quotient rule. Look how fast it works out. You just treat the x to the 4 as a common denominator. And then you reduce. So notice x to the 5 over x to the 4 just leaves you with a single x. Here, the x force cancel, so that's nice. Here you have x to the 3rd takes away all but one of those. So then I just take the derivative of these guys. The 5 just goes away. Here you get negative 7, and then here I just use the rule 3 to the x, the derivative of 1 over x is negative 1 over x squared, and the 3 just goes along for the ride. So there you go. So those are the second 3. Any questions on those? By the way, I can't see the chat, so you might have to pop in verbally if you want me to see something. All right, let's move along. So 7, 8, and 9. For 7, you have x to the 9 power times cosine. And here you have to use the product rule. There's no way around it. So I just did first times derivative second plus second times derivative first. Actually, it's the other way around. Second here times derivative first. And then I just did a slight little bit of cosmetic manipulation. Just looks a little cleaner here. Number 10. Oh, it's tan x times the quantity 7 sine x plus 2 cos x. I debated on this one. This one can be done either doing the product rule or multiplying through. And I found that if you multiply through, you still have to use the product rule. So I figured, just use the product rule. So it's the first tan x times the derivative of the second, which is 7 cos x minus 2 sine x, plus the second, which is 7 sine x plus 2 cos x, times the derivative of the first, which is secant squared. And I wrote, this can be simplified, but that was optional. If you had this, it should have been accepted. Number 9, let's see, we got y equals square root of 9 minus 2 tan x. Take the derivative. So you got the 1/2, the whole thing to the 1/2 power. So the 1/2 to the front, the base without any changes to the negative 1/2. That's the power rule. Then the chain rule comes into play. You take the derivative of the base and put it right here. The derivative of 9 is 0. The negative 2 is just going along for the ride. Derivative of tangent secant squared. And then you'll notice, first of all, this negative here is this negative here. And the 2 here takes out the 2 here. And this is the answer in simplified, or at least more attractive form. Oh, I made it rectangle. How about that? All right. Questions on that one? Again, stop me at any time. 10, 11, and 12. You got a whole bunch of 9s here. You got 9 cosine 9x minus 9. And we want to find its derivative. You're doing the cosine rule, which is the negative sign of the interior. Then the chain rule of this guy gives you 9. So the derivative of 9x is 9. The derivative of negative 9 just goes away. So then all I did was take the negative and the 2 9s and make a negative 81 in front. Looks pretty. Number 11. All right, let's see what's going on here. Bring the 3 down. Got negative 9 cosine cubed x. By the way, that's the same as cosine x quantity cubed. Bring the 3 down in front. You get negative 27 cosine squared x. And then the chain rule. Derivative of cos x is negative sine x. And then you'll notice that the negative here and the negative here cancel. You're just left with the leading 27 cos squared x sine x. Number 12. You got quantity, you got a strange one here. Quantity negative 9x squared plus 3 to the 7th power times 6x squared minus 2 to the 9th power. Now in this one, you probably want to use the product rule, but notice that it also uses the power and chain rules. You got a lot of stuff going on here. So it's the first, which I just copied here, then the derivative of the second. So bring the 9 in front, 6x squared minus 2 to the 8th. And then the derivative of the inside is 12x. That's where this 12x comes from. And by the way, I'll just jump to the step. 12 times 9 is 108. So the 12x and the 9 make 108x. I just moved that out to the front. Okay. Now, then we have the second, which is 6x squared minus 9, 2 to the 9th power times derivative of the first. So bring the 7 down. You have negative 9x squared plus 3 to the 6th power. Oh, I need to fix that, it looks like. It's going to be a 6. I'll do that right here. All right. And I also made a mention, oh, by the way, so and then the derivative of the inside is negative 18x. And then I took the negative 18x and the 7, and that gives you negative 126x. I would not waste time trying to simplify this out any farther. It's not worth the trouble. And I also wrote that log differentiation would work here too. I didn't work it out that way, but this might be a time where logs help. Any questions on 10, 11, and 12? All right, let's see what we got next here. Let's look at 13, 14, and 15. Now we're getting some ln's and e's. Here we have natural log 6t squared plus 3t plus 7. The derivative of the ln is just simply to take whatever's in the parentheses and move it to the bottom. And then its derivative on the top, chain rule. That's it. That's all you do for the ln derivatives. And since this 6t squared plus 3t plus 7 is simplified, it can't be factored or anything, then what you get here is simplified. So you don't need to worry about factoring anymore. Number 14, natural log of the radical of the quantity, 8x minus 2 on top, 7x plus 3 on the bottom. Notice that the square root here is actually the same as this whole mess to the 1/2 power. So that just moves out in front. That's not the derivative, okay? That's just a rule that the natural log of an argument to a power is the same as bringing that power in front times the natural log of whatever that argument was, a for argument. Okay? And then notice that this division line becomes this subtraction line. So this division line is this subtraction line. And then we just perform the pair of derivatives. Here you got 8x minus 2 on the bottom. Chain rule gives you 8 on the top, pardon me. Here you got 7x plus 3 on the bottom. Chain rule gives you 7. And I'd leave it. That's finished. Number 15. You got to take the derivative of e to the radical 5x plus 2. So you just copy the function entirely as part of its own derivative. But then you've got the chain rule. You got to work out the chain rule of the derivative of radical 5x plus 2. And I would recommend that you memorize the radical derivative. It's 1 over 2 rad x, and then of course the chain rule. And that's simplified. There's not much else you can do with that. Again, pause here for a moment. Any questions? Yogi, 16, 17. Let's see what we got here. Function was e to the 9x on top, 2 plus e to the x on the bottom. This one is really only, quotient rule is really the best way to do it. I guess it's not the cleanest, but it works. You have bottom 2 plus ex times derivative of top minus the top e to the 9x times derivative of the bottom, which is just e to the x. And then I distributed here, you get 18 e to the 9x. Here you get 9 e to the 10x. And then you get negative e to the 10x. That's actually 8 e to the 10x. That's where that came from. And leave the bottom alone. Don't fill it out. I also wrote that log differentiation would have worked well here too, but I don't think it would have been that many fewer steps. I think this is a case where it wasn't too nasty looking. And the quotient rule, you know, it's nice. My usual rule is don't use it unless you have no other choice. Number 17, find the derivative of 8 sine inverse of x squared. You just have to memorize the arc sine derivative. This is going to be pretty common. You're going to see this a lot in Calc 2. The arc sine and the arc tan are really common functions because they pop up a lot in Calculus 2 when you get to series first. That's just the way they show up. So the derivative formula for arc sine is 1 over radical 1 minus quantity squared. So here the quantity is x squared. So that actually goes right here. The derivative of x squared is 2x. That goes up here. Leading 8 is just sitting out front. And then I just cleaned it up. 8 times 2 is 16x. And then you get x squared. Squared is x to the 4. And let's see if it makes that neat little box again. I guess it didn't do it this time. All right. Any questions on those two? All right, let's look at the last couple here. Look at 18 and 19. Another one that involves this one involves arctan. It's x to the fourth times the arctangent of 2x. Yeah, this one you're pretty much stuck using the product rule. So it's the first x to the fourth times the derivative of the second, which is, again, the derivative of arctan is 1 over 1 plus quantity squared. So the quantity here is 2x, so you square it. And then the derivative of the 2x is 2, so it goes on top. And then you do the second, which is arctan 2x times derivative first. And then I just cleaned it up here over on the right. So it just made it look pretty. Number 19, this one is just a weird looking power rule. Bring the 4/7 down in front, leave the base alone. New power is 4/7 take away 1 if it's negative 3/7. And then you do the chain rule and you get the inside, the derivative of the inside. 9, well, that's actually negative of 2 times negative 1 over t squared. The negatives make a plus. All right, number 20. This one required a few steps. Find the dy dx by implicit differentiation. So we're going to differentiate both sides with respect to x. That's what these guys are. These are operators. So on the left side, derivative of 9 is 0, derivative of 2x is 2. On the right side, we have cosine times the thing, x to the y5. I'm sorry, x times y to the 5. And then you got to do the chain rule. So believe it or not, here you have a product rule that's going to have to be done as the chain. This is all the chain rule right here. All right. And so you first times derivative of the second, so 5y to the fourth dy dx, because we're taking the derivative of y, that's the chain rule, plus the second y to the fifth times derivative of the first, which is 1, dx, which is 1. And then from here on out, I just cleaned it up. I distributed the cosine xy to the 5 through, and then I just started moving stuff around. So like this term on the right here goes to the left side with a negative sign, and then divide out by this thing here, and you get the answer. Dy dx is 2 minus y to the 5 cosine xy to the 5 all over 5xy to the 4 cosine xy to the 5. Boom. All right. Oh, sorry about that. All right. Any questions on those last two?
I'm just curious, is there like a trick that you do when you do implicit differentiation to kind of like um keep what would be not a part of the dy dx that's divided out and everything else as you're kind of working through? Because I think that's my biggest issue with implicit differentiation is like keeping everything organized when I'm just working through it. Does that make sense?
Oh, yeah, it does. And actually, there's no trick. You do have to just keep it organized. Um, just be really careful and methodical. I
I
tried to
got you.
show all the steps. I think you
Yep.
can appreciate it. It's ugly, but if you're
Yeah.
careful, it should work.
I see the parentheses and that kind of like in my head helps me at least, like how you have it grouped together. But yeah,
Okay. Yeah, there's no trick. Unfortunately, they're just ugly. Um, when you get to Calc 3, funny enough, they'll actually show you a method using partial differentiation that actually solves these pretty quick. But nevertheless, you're still kind of stuck with like product rules and stuff. So unfortunately, you just have to work it through.
I got you.
I can go over any of the first 20. Anybody have like one they want to see a little more in depth? I'm scrolling slowly, just say stop.
I just had a quick question about 9.
Okay.
So I guess I might have been overthinking it, but whenever you have something grouped by the radical, you can't drop that 9, right? Because that has to stay. Because I was thinking uh like I was like skipping the step of raising it to the half. I was just doing 1/2 radical. I'm like, do I drop it or do I keep it as a constant for that 9?
You have to keep this entire radicand unchanged in this first step.
I gotcha. Okay, that
Right? You
makes
don't really have a choice in the matter there. You actually doing, I would say this, just kind of blur your eyes and say, it's the square root of something. And then just verbally say it to yourself, what's the square root of something? It's going to be 1/2 square root something. So that's what I
oh,
have right here. It's 1/2, then you got this square root something. It's actually still -1/2. And then worry about the chain
okay, yeah. I think I was just overthinking it when I was working it through in my head.
rule. All right, again, I'll continue to scroll slowly. Stop me if you see a question. All righty. Make sure you know your arc sine and arctan for Calc 2. Differential equations too, fun. For some reason, they pop up a lot. All right. Well, that was it. Any questions on that? Any other last questions before I stop the share? Okay, I'm actually going to stop the recording